Welcome to another video solving for the horizontal projectile. In this question, we have an object that is launched horizontally from a height of 20. So here we have this object that is thrown horizontally 20 meters above the ground. So here's the y-axis, and starting from 20 meters above the ground, taking the reference to be on the ground, with a speed of 15 meters per second. So the V initial is 15 meters per second. Firstly, we need to determine the time at which it will hit the ground. So basically, the projectile will follow this trajectory, and when hitting the ground, it will undergo horizontally something we call the range. Now let us recall the useful equations of the projectile. So here we have delta x. For delta x, we use vi cosine theta times time. And for the vertical displacement, we use negative half g t squared plus vi sine theta times the time of travel. And finally, if we want to find the vertical component of the velocity at any time, it is equal to minus g times t plus vi sine theta. Now firstly, to find the time at which it will hit the ground, I will be using the second equation, knowing that delta y underwent is actually y final minus y initial, which is finally on the vertical it will reach the 0, minus initially was at 20, so the vertical displacement is negative 20. However, replacing everything by its value in the second equation, half gt squared plus vi sine theta time. Now let us replace everything by its value. We will have negative 20 equals to half 9.8 t squared plus vi, which is given 15 meters per second. Now sine of theta, because the object is thrown horizontally, so basically the theta at which it was thrown is 0 degrees times the time. Now the only unknown is the time. After computing, I will have that the time equals to 2 seconds. Now in part B, I need to find the horizontal distance traveled. The horizontal distance traveled, or also I call it sometimes the range. The range or the horizontal displacement or distance. Now after finding the time at which the time of travel before hitting the ground, let me replace the time in the range. Now delta x equals to the initial velocity by cosine of theta of lunge times the time of travel, which is 15 by cosine of 0 times 2, which will give me 30 meters. Lastly, I need to find the speed with which it hits the ground. Now finding the speed, this means I need to find the resultant velocity. Now going into the picture, the illustration, I can see that the object keeps its horizontal velocity component constant, and that's because there is no force acting along the x-axis. So this velocity is always 15 as the initial velocity. However, during the time of travel, I have an increasing downward vertical component which I can find at any time by using this equation. At any time. After I find the vertical component, to find eventually the velocity of impact, the velocity at which it hits the floor, it is nothing else than the resultant of these two vectors. So I have two steps to do. Firstly, now this is the velocity I need. So firstly, I need to find the blue arrow using, I have to find this blue arrow using this equation, v final y equals to minus gt plus vi sine theta. Once I have it and I have the 15 horizontal to the right, I will find the black arrow, which is the resultant of these two components. Now, firstly, I will list my givens. So this velocity that I'm looking for, which is the black one, so this black arrow, this velocity has two components again, the 15 to the right and the blue, which I will calculate now, v final y. Now again, v, the speed at which it will hit the ground, applying the Pythagorean theorem, it is vx squared plus vy squared. This one is 15. Now let me look at this. Finding it, v final y equals to minus gt plus vi sine of theta. So minus 9.8 times 2 plus 15 sine of 0 will give me a negative 19.6. Now that I know it, 19.6 negative, I will go and find the velocity of impact, which is 15 squared plus negative 19.6 squared, and it will give me 24.6 meters per second. Thanks for watching.